So I wanted to record this video to help you through the chapter, what is it, the chapter 5 stuff with all the binomial distributions and all that. So I'm not going to do all of these because they're kind of self-explanatory. Plus, you can find some of these answers in the book already, the worked out answers. Because like this rolling a die one, there's one like that in the book. So I won't do that one for you. What I really want to focus on is a couple of problems that always give people a hard time, and then the binomial calculator. I mean, I hate to see people have to use those formulas for it because often they make a mistake. And I mean, as long as you recognize that there's a binomial distribution going on, that's the important part. Okay. So here's one problem. This is problem number 3 in the assignment for chapter 6 that gives people a hard time. These warranty questions. And some of this is a little dated, but it has applications across the board with different situations. So I buy a cell phone for 90 bucks and there's an 8% chance it'll fail. Uh, I can pay an additional $10 for a hassle-free warranty. Well, AppleCare costs a heck of a lot more than that. But anyways, it means if you fail, you get a free replacement. And you choose not to buy that $10 thing. Now, one thing mathematically will do it. The other thing to consider, all the mathematics, all the mathematics apply to the long run behavior. So, I mean, warranties, you probably heard the thing that warranties are so companies can make money, and you shouldn't buy them. Well, some things and sometimes I'll buy an extended warranty just because I mean, when they sold me my Toyota, a few years ago, they said, there's 50 computers in here and they could all go and it's worth spending that extra extended warranty. They sold me on that. And of course, I never used it, so I would have been okay. Um, but what if? So it's your safety of mind. And then with these phones, I mean, in the long run, yeah, the company's going to make money by selling you the warranty, but what if, my daughter takes very good care of her cell phones. She never drops them. So she never buys the Apple Care. She likes iPhones. And she's right. I mean, as long as you take care of it, but what if, what if you crack the screen and what if something goes weird in it? So, anyways, how does this problem work? That's not pontificating. I want to do this problem. So if it fails, so here, let's just talk about this. If it doesn't fail, I'm only have to buy the phone once, and the probability that it won't fail is 92% or 0.92 because it's only 8% chance that it will fail. Okay, so I'm gonna put 9.92 point 92 because it's 8% chance it'll fail. So the probability that it will fail, and I'll have to buy a different phone is 8%. So if I have to buy two phones at 90 bucks a phone, that's going to cost me 180 bucks. And then this is just a weighted mean like we did back in chapter 3 and in chapter 2. You just multiply 180 times 0.08 plus 90 times 0.92, add those two numbers together, and you get the expected value for the cost of this phone. Now, here I'm going to pause this, go grab a calculator and do that. So when I just did this on my calculator, I got this top one was equal to 1440, and the bottom one got 8280. And when I add those together, I'm going to get, let's see, what is that? 20 carry the one. If I'm doing this right, 6, 7, and so 9720 is what the expected value for this phone. So if the if the company does this, I mean, if I don't buy the warranty from them, I'll spend 9270 on it in the long run. But so then if I do buy the warranty, so if I go back and if I were to buy the $10 warranty, I would spend $100 on this. So that means in the long run, um, they're going to cost these phones. Let's see, how do I word this? They're going to take in $100 in the long run. The phones are going to cost them 97.20. So that means they're making $2.80 profit on every phone with warranty that they sell. Okay. So um, what this exercise is asking you to think about, well, yeah, if I buy the phone with a warranty, that's costing more than what the expected value is in the long run. So yeah, it's not worth it to buy the warranty. But like I said, we're individuals and anything can happen in the short term. Hopefully pick that up with the all that work we did last week with probability. Okay, so that's one that people have a hard time with. And then um so this life insurance policy is exactly the same kind of question. People get stuck with this. And there's one like this in the textbook that I think that's been worked out. So what you do when I do this one, I set it up, I'll set up a table. Let's see. I'll set up a table. He dies, he lives, and and here's the cost, and here's the probability of that happening, and of course we're going to multiply those. So let's see. If he lives, the probability of him living will be 0.9997, and the company, so the man bought the policy, and it cost him $70. So um, this is from the insurance company's perspective. So there's 70. If he lives, they can take the $70 premium and they can go on their merry way and pay everything they need to with it. But if the guy dies, they're going to have to pay out $100,000 policy. And let's say the probability he's going to die, remember, is 1 minus that. So 0.0003 is what you should get when you do it on a calculator. And then they already got the $70. So they aren't going to have to pay out $100,000. They got the $70. So they're going to have to pay out 9,930, I think. I think that if that adds up. If I add $70 to that, doesn't that come up to be $10,000? So then what you can do is and I won't bother finishing this one because it's just like the warranty. Multiply those two values, multiply those two values and add them together. And that's the expected value on the prophecy. This is so from the insurance company's viewpoint, it's going to come out positive, and that's what they'll make on every policy they sell. And it represents the profit in every policy sold. The rest of the average profit. Uh, well, yeah, actually, I think that's choice C is how I would word that because it's the average profit if you sell a lot of these policies, right? Because if they just sell one policy and the guy dies, they're out a lot of money. So they try to sell a lot of these policies so they have that nice hedge. Okay, that's what's happening with our homeowners insurance right now and auto insurance policies. They're having so much cost in other states that they crank everybody's rates up. Probably you knew that. So here, let me clear off all my drawings. We'll come down to another problem. And again, this is one I don't think I need to do. You're just going to take a look at the examples in the book and watch Dr. Stevens' video, and you'll find out about it. There's 4 criteria that has to be met to be a binomial distribution. Now, this question here, number 6, I think it is, they tell you to use the formula or software or calculator. You can certainly go use the table. The tables work. You can even certainly use the formula. What's nice about using the formula is we're looking for exactly 4 out of 10 successes. So that's just this one calculator. Where it gets messier is when you're looking for like less than 4 or greater than 4, and you got to do a bunch of those calculations with a formula. And that's where it's a pain in the butt. So what's the easy way to do these kind of problems? Well, if you recognize it as a binomial probability, here in Canvas, I have modules, and then in course resources, well, let me think it all. In course resources, I have, where do I have online statistical tools? And here's so this is the calculator I'm going to point you towards is the binomial calculator. This is that GigaCalc calculator. If you've watched another of my videos where I talk with StatTech, it's the same kind of calculator. But so all you need to do for this calculator is let's go look at that web assign question. Whoops, not that one. I got to write this down here just a minute. So I see I want 4 successes. So X is 4 out of 10 trials, and the probability of success is 70%. So P equals 0.7. So you just go to that stat trek calculator and you'll do the probability is 0.7. We'll do number of trials is 10 and number of events is 4. And you click calculate, and then you're going to see all these probabilities. And so you got to decide which one you want. And because we want exactly 4, see how it equals to 4? That's the answer that WebAssign is looking for. Okay, on a quiz, if it's a show your work quit part of a quiz, I want you to screen capture this and indicate which probability you're looking at. Okay, and that's sufficient work. You don't have to crunch the crunch formula or use a table. Okay, so that's that question. Let's see. Oops, not there. There. Yeah. Now the next one is 4, less than 4. It doesn't include 4. So what does that mean? Doesn't include 4? Well, if you go, I'm going to use that same stat crunch calculator, that GigaCal calculator, but I do want to show you a picture of what's happening. Sometimes that helps. This histogram calculator also does pretty well. Let's see, I got to go back and look at what they're asking us. I didn't write that down. Nope, not that one, not that one. Is it this one? Yeah. So it's less than 4. X is less than 4. It doesn't include 4. So X is less than 4, N is 10 again, and the probability is 0.3 this time. So if I go back to that histogram calculator, let's see where it's at. That's the stat track. Here we go. N is 10, probability is 0.3, and I want, does this do less than? No, this just is inclusive. See, so if I type in 4 here and have it calculate it, I want to go less than 4. Okay, see how that probability includes the 4 bar, the 3 bar, the 2 bar, 1 bar, 0, and that's that probability. Well, that's the wrong probability because that includes 4. The problem was less than 4. So the way you use this calculator for, and just so you see the graph, I'm going to change that to 3, let it update. Do you see how now that's going to be less than 3 or less because it's inclusive? So that includes the probability for 3, the probability for 2, the probability for 0, the probability for 1. So that's if you're going to use the formulas, you'd have to do probability for 0 with a formula, 1 for 0, 2 for 0, 3 for 0, and add those up. Alternatively, I guess you could do probability of 4, 5, 6, 7, 8, 9, 10. Of course, the probability for 8, 9, 10, or even for 7 is pretty close to 0. So, I mean, you couldn't just say there's 0 because of WebAssign, but because you know how picky those online systems are. But this is what you're doing. So now let's go back and use that GigaCalc calculator. So the probability is 0.3. I get 10 trials, and then we got 4. So we don't have to do the 3 here because here's what this is giving us. Do you see how right here, that says the probability that the event is less than 4. It doesn't include 4. This one right here includes 4. This is exactly 4, and we don't want that one. We want less than 4. So that probability is what, 0.6496. If we go back to that histogram, 0.6496. See how we're getting that same answer? So that's when it's less than, you'd want to include it. That's how that GigaCalc calculator works. Okay, so hopefully that's convincing. Oh, I think I will use that. Here it is. And here's 2 or higher. So I'm just gonna go use that gig. So that it would include the 2 bar all the way up to the 6 bar, and the probability is 0.6 if you're gonna do. Let's go do the histogram because I think it helps to see it. So there's 6. It was 2, and let's see. Then it was short-term memory problems here. Oops. Probability was 0.4. Okay, and I want to change this to greater than or equal to. Do you see how that does that? Includes 2 all the way up to 10. That's what they're saying. If we go use that calculator, what is this? Like I said, short-term memory problems. Um, 2 or more. So probability is zero point 0.4. I have 2 and 6. Zero point 0.4, 2 and 6. So 0 0.4, 6, 2, not 25, Dan. 2, that would give me an error. Calculate. And then you can see 2 or more is right there. And hopefully that number agrees with the histogram 0.7667. 0.7667. Yep. Okay. So see how that, hopefully that works. Hopefully this convinces you to go embrace this calculator rather than doing the formulas or the tables even. I mean, because like I said, the challenging part is recognizing it's a binomial distribution. Okay. So then we get in, and this is really this was the real reason why I wanted to do this video. Now we're getting to a situation where we have a pretty large sample. Okay, so this goes back into uh, the end of chapter 6 or chapter 5, where he talks about there's a shortcut. Do I have my book? Let me grab my book here, folks, and I can actually let me pull it up on screen. I'll pause this, pull it up on screen just so you can see what I'm talking about. Okay, I don't know if you remember me saying back for the first exam, we talked about from here on out, every distribution we look at, we want to know what the shape is, what the center is, what the spread is. And what center and spread we use is based on the shape. So here they talk about the mean, the standard deviation. They'll say there's a shortcut we can use with plus or minus 2 standard deviations, just like we did before. But that only works if the distribution is normal. And then he has this hidden really right here, and people overlook it, but it's so crucial. In order for you to use that shortcut, you're going to take your sample size times the probability of success and multiply them, and that's got to be 5 or more. Um, and if then you do the sample size times 1 minus the probability of success, the Q, and that has to also be bigger than 5 because it's one or the other. We don't have a normal distribution. I think a good way to show you this is to go look at that. Uh, histogram calculator. Okay. Um, let's see here. So we're going to hear what I'm going to do is I'm going to use this problem as an illustration. And maybe I've already done this in another video, but I want to make sure I include it here. 1.86 is the probability of success, right? That 18.6% of the people are uninsured. And we're looking at a sample size of 300. Okay. So let's go look at that. Go look at that binomial distribution calculator. So we've got 300 people. We've got a probability of success of 0.186. And we're just going to get rid of the 5. Okay. When I do this, I see a pretty symmetric distribution. In fact, during week 7, we'll call that a normal distribution. And for good reason. Then we can do some stuff with the normal curve with it. But for now, we just see it's a symmetric distribution. So we're going to use, we can probably use that mean and 2 standard deviation shortcut. But the other check is we got to make sure that when we do 1 minus 0.816, let's see, what is that? I'll do that here on my paper. I guess I could do it with a calculator, but let's see. I'm going to borrow the 0. No, I guess you don't have to hear me talk this through. Let's see. So I'm getting 4, 1, and 8. So 1 minus that is 0.814. Oh, no, it's going to give me an error because of 0 0.0. Let's see, Dan. There we go. And we see that also looks normal. So yeah, this is good to go. They told us that it was going to be, but you want to check it anyways. What happens if they only gave me a sample size of 30 with this? Well, let's see. You see how with a sample size of 30, it's not looking symmetric anymore. It's looking kind of skewed. So one thing you can do to check is here, I guess I'm going to pull up my on-screen calculator, um, the license expired, so I don't have access to that today, and I haven't taken the time to go get it redone. So I'm just going to do it right here. Calculator, so you can see that. So if I do 30 times 0.814, we see that's bigger than 5. But remember how the other ones we have to do we have to do this is the probability of a failure. Now we're going to type in the probability of success and see if that's also bigger than 5, and see that's not looking very symmetric. Now maybe the calculator will show us it is Dan LeMay, what'd you do with the calculator? I took it here. So I'm going to do 30 times 0.8184. So, well, that's just barely greater than 5. So but it's using the rule that would satisfy. We could still use that mean and two standard deviation shortcut. I mean, if this were, let's cut this down to 10, say. If it's 10, clearly it's not symmetric. And 10 times 0.186 is only 1.86. That's not greater than 5. So that wouldn't be valid to use that shortcut. We'd have to go use a GigaCalc calculator for that, okay? So anyways, let's go back and answer that. That's probably I've rambled on enough and lost you. Let's come back and take a look at that web assigned question. So I did the check to make sure that n times p and n times q is bigger than 5. And then we got the mean. Now, if you had to calculate the mean by hand. I mean, of course, that histogram calculator actually gave it to us, but I think this is worth knowing how to do by hand. So the mean is the same as n times p. So I'm going to take 300 times 0.186, and that was, I don't remember what it was here. I won't go back to my calculator. I'll just use it here. 300 times 0.186, I'm getting 55.8. So that's the mean of this binomial distribution that's approaching a symmetric distribution. And then you get the standard deviation. It's that same n times p times q, or 1 minus p. So we'll do 300 times 0.186, which we already have that answer, times 1 minus p, which I did earlier, got what? 1.814. And then I'll take the square root of that. So I'm just going my calculator. I got 0.558 for the n times p. Now I'm going to times that by the 0.814 number. I got 45.4, and I'm going to take the square root of that. So I'm getting a standard deviation of how many decimal places? One decimal place, 6.7. Then they're asking to get the z-score. Well, the z-score, remember, it's the measure we're interested in minus the mean divided by the standard deviation. And if we get that, let's see, what do we get? We get 71 minus the 55.5.8. We got 15.2. Then we divide that by 6.7. I'm getting a z-score of 2.27. It's above the mean. It's 55. Let's see, 71 is above the mean, so it should be a positive z-score. So 2.27. So is that more than 2 standard deviations away from the mean? It sure is. We consider it to be unusual, or it's an outlier in the situation. Okay, and so that's how that works. And I think you just have a couple more exercises that are similar to this, that are just like that. So I don't know if I need to do any more videos, make this video any longer. Yep, see, there's just another problem. There's one like this in the textbook, the goodbye electronics. Okay, so hopefully this helps. Give a yell. Good to ask in the forums. I encourage you to go use that GigaCalc calculator. That's what this calculator is right here. And of course, that's that histogram calculator. It's kind of cool to see it, but I don't think that's as useful a calculator. Okay, so this is a long enough video. Let me know if you need some help.